Due to some differences between how graphing calculators and Desmos operate, Project 2.10 will require us to either get a little creative and sort of reconstruct the questions being asked in a way that makes the problem more accessible, or we'll have to consider retyping data sets a few different times. But we'll discuss that as we go. In this project, what we're asked to do is have students collect information about themselves by taking measurements on their height, arm span, wrist length, foot length, etc., and then construct scatter plots, investigate the relationships between those two variables. So once students have collected the appropriate data, we can go ahead and open a blank Desmos document and insert a table. Initially, that table will only have 2 columns. What we can do is go ahead and change the variable names there to give those columns a little bit better context. So for instance, we could change this to H for height, A for arm span, and if we wanted to add one additional column here, we could call this F for foot length. The table has additional measurements that you would take, but just for simplicity's sake, we're going to look at these 3 columns. Once we have our columns set up, we can go ahead and enter our data. We can enter these values as decimal answers, so for instance 64.5. Or we can also use a mixed number format. So we could type in 70, hit the space bar, and then type in the fraction 1/2, and Desmos will automatically translate that into that fraction notation. We can press Tab or the right arrow key to get out of that fraction notation, and then once more to skip to a new cell. So using decimals or mixed number notation, we can go ahead and fill in this chart. So I'm going to go ahead and pause the video while I input some of this data, and then we'll look at how we can actually investigate the questions that are being asked in this project. With the rest of this example data entered in, now we can explore how Desmos is going to allow us to view and interact with these 3 columns of data, or more if we were to include the additional variables. Right now we don't see any points plotted, but if we zoom out, which we can either do with the plus and minus keys, or I'm going to use the mouse wheel on my mouse, I can just zoom out until I start to see some of these points show up. Then holding and dragging, you can reorient your screen until we see those points showing up where we want them. I can see from just glancing here that I have a very unusual point occurring, which I'm going to guess means that I made a typo. And it does look like over here I typed 31.5 instead of 61.5. So with my data corrected, now we can see 2 different groups of points, each corresponding to one of the colored circles here. So if we want, for clarity's sake, to focus on one particular set of points, we can click on those circles to turn off a set of points, and vice versa. So what we can sort of see here is that even though we have these 3 columns of data, what Desmos is going to do is consider our first column to be our independent variable, and then it is going to separately pair that with each of the remaining columns as a separate dependent variable. So what we're getting are the points h1, a1 represented as these green points, and the points h1, f1 represented as these purple points. And if we continued to add additional columns, when we included those new points, it would be continuing to pair h1 as our independent variable with a new dependent variable. This is where the difference between Desmos and the graphing calculator tends to show itself. If we skip ahead and look at question 4 in the book, we're going to be asked to use the graphing calculator to create scatter plots for these different pairs of data. Using a graphing calculator, that's pretty straightforward once you have the data sets entered in, because with your scatter plot you can choose from any of the different lists stored in your graphing calculator. With Desmos, the only thing we're going to be able to do with this table as it's typed in is compare h1 to some of those other variables as our dependent variable. So at this point in the problem, you would either want to rework this table, present something else to your class where instead of looking at height versus foot length and arm span versus wrist, to explore height versus each of those other dependent variables. Or what you would need to do is retype the data. So we would need to actually in Desmos insert a new table and then retype the data points that we would want to compare. So for instance, in arm span versus wrist, we would need to create a new table where we input those values again, and that would actually give us that independent variable, dependent variable pairing that we're looking for. But then what we'll be asked to do is determine a linear regression equation to represent the relationship between the two variables in problems 3 and 4 that show the strongest linear pattern. That part will be similar to what we've done before. What you'd want to do is just take whichever variable you're interested in pairing. So we'll start off with h1 as our independent variable and a1 as our dependent variable. And go ahead and set up that regression equation, where what we're doing is typing in something of the form y equals mx plus b, using that tilde symbol in place of an equal sign to indicate that we want that regression process to be completed. Making sure we're paying attention to what we're selecting as that independent and dependent variable, making sure those correspond with the appropriate letters at the tops of those columns. And then I've just called this m1 and b1 so that I can create a second regression equation still using m and b and not have those different constants cross over with each other. Once we create that regression equation, we have our correlation coefficient and the values for m and b. So if we notice the strongest correlation between arm length and height, that would be the regression equation we wanted to complete. If we notice the strongest correlation between foot length and height, we could construct a second regression equation, or we could construct this alternate regression equation since we're only being asked to construct one. So again, what's changed here is I've referenced that different variable, f1 instead of a1, and here I've just called these m2 and b2 to distinguish between the m and the b that were used initially, but I'm still referencing that same independent variable, that same h column for height. For clarity's sake, there are a couple of things that we could do here as well. For instance, if we just want our lines and points to match up, we can again hold down on that circle icon. We could change the color of this graph so that we get our line matching up with the same color as our points. And similarly here, we could change this to a purple line just to help students see which lines are connected to which points if things were closer or more cluttered together. Moving on to the remainder of this problem, we're going to be a little bit stuck with the existing table because starting in part 6, what we're going to do is look at predicting height from the length of the femur. So in this case, height is our independent variable, but what we'll actually want is the length of the femur to become the predictor. So what we'll do is just start a new table where we could call this F3 for the length of the femur, H3 for height, and then we could basically repeat the process that we've already gone through here. Enter the values for the length of femur, enter the values for height, construct a regression equation, and follow along with those remaining interpretation questions.